Hello, everybody. Once again, greetings to all the participants of the webinar. And as Christian told you, I'm going to give a presentation about the implementation of the traffic control center model of RITM³ system at the scale of millionaire city of Chelyabinsk. So let's go. But first of all, before we start, I would like to tell you some words about the national politics in the field of transport. So this is partially overlap with the first speaker. As we remember, he told us that for many years, the field of transport in Russia was almost deprived of government attention for many years. But later on, the situation has changed, and the first steps on the field were focused mostly on the infrastructure renovation, on the road repairment, and just, let's say, 10 years ago, the first ITS projects started in Russia, mostly in Moscow, because as a capital city, Moscow adopted these international practices first in Russia. But recently the situation has changed, and the government issued a decree, and the national project of the Russian Federation called Safe and High Quality Roads started. So this project has several directions, and one of the key directions within this project is devoted to ITS. So there was a statement that, according to this decree, that implementation of ITS in every agglomeration with more than 300,000 inhabitants within the country. So every city, let's say of moderate size, has to have an ITS system for traffic management by the end of the current decade. So altogether, there are 75 such agglomerations in Russia. And according to the document, 22 of them should already have their ITS systems implemented by year 2024. Okay, let's speak about the case of Chelyabinsk and what is the city of Chelyabinsk itself? What are the specifications for this city? Well, this city is located in the southern Ural region in Russia, and it has about 1.6 million population in there. It has a large area and about more than 2,000 kilometers of roads. Also, Chelyabinsk is famous for its industry, like different weaponries, metal industry, and so on. But as any other Russian city in the province, it has poor state of public transportation. It has poor quality of road infrastructure. And another big issue for the city is the unfinished metro construction. 30 years ago it started, but due to the lack of financial opportunities, it was frozen. And now, as I know, the authorities don't want to finish this construction, and instead of metro, there will be some kind of speed tram. Also, the congestion and the traffic jams are big problems for Chelyabinsk because, according to the ranking, it hosts the 7th place, so it's the 7th most congested agglomeration in Russia, while being only 9th most populated. So we see that traffic jams are likely to occur in this city. Well, in order to manage transport system well, you have to have some center. And prior to implementation of the RITM in Chelyabinsk, there was a quick response center for the traffic management, which was mostly focused on the traffic light regulation. So it has a big video wall consisting of plenty of screens, and you can see on the picture. So it's quite inconvenient to work with this wall, because each screen has its own data. It's hard to combine everything together to make an efficient decision making. So at the moment of, let's say, 2 years ago, according to this decree of the government, the Chelyabinsk authorities decided to, so they asked our company to provide them an innovative system for effective transport management in the city, because they faced a lot of difficulties with their own, let's say, version 1 center. So it was it was clear for everybody that you have to increase the decision-making abilities in this center. So you have to have only a single interface for receiving the whole data and to process it. Also, you need the authorities told us that they needed a strong prediction tool. So not only working with the real-time data, but to forecast in order to increase the management performance. So at December 2019, SIMETRA started this project in Chelyabinsk. So it was an implementation of the traffic control center model of RITM in Chelyabinsk, and the work itself commenced with the data acquisition. Also, there was a creation of the interactive layout of this center interface. All this data in the interface was coordinated with the authorities, of course, and we did some work on integration of systems for online data transfer from different sources, from different external sources into RITM. And finally, based on all this work, some kind of final model, final layout on this basis was built. And of course, during this work, we faced some problems and issues. First of all, of course, if you want to build a good ITS system, you have to provide an effective data integration into your system from external systems. It's a must, because the data transition should be fast, because otherwise you cannot really talk about the real-time management. And of course, initially, not all types of data was included in the initial layout. So we decided to implement a single universal data block structure, where we can combine all the requirements together. So having this proper structure, we can create a traffic control center of any complexity and scale. And we actually we made a project. We built this block structure for this traffic control center. On the screen, you can see this diagram. So there are many components which together build this traffic control center. So you have visualization tools, you have data processing tools, you have analytic tools in there. So all together, combined, is a traffic control center. As the outcome of the work, the city of Chelyabinsk received the traffic control center based on our RITM. And you can see here an overall view. So we have the GIS map, the master plan of the Chelyabinsk and its outskirts. And of course, you have some data in time. you can see the weather conditions. Underneath, you have a widget panel where you can find all the widgets and analytical tools embedded in there. On the top side, you have these buttons which you can activate, and this is actually buttons for different layers. So let's go through all of them and concern them in details. So first is the road engineering layer. What is this? Actually, this is a layer which you activate, and you can, while activating this layer, you can do monitoring, tracking, and analysis of the fleet of road engineering vehicles. There is also statistics. So there is a split between different service providers within the city. So you can find there the statistics related to any group, and you can track any vehicle inside the city. The next one we discuss is the traffic lights layer. As you saw on the previous slides, so this big diagram, the GIS map of the city, there are places where the traffic lights are located, and you can see on the traffic light widget, you can see the overall statistics about the objects operating in the city. So if something happens to a single unit, you will immediately see it on the interface. So you can manage the problem just within a seconds. So we see these statistics. And also what is quite interesting, you can switch to any unit and you can see the design of the junction in there. So to analyze the situation there. And with this layer, you can analyze the overall status of traffic lights in the city. So this is quite convenient. The next layer we discuss is the public transport. So here, again, you have all the fleet of the public transportation in the city. In real time, you can switch to any unit and follow the tracking. You have a statistics of the vehicles on the route divided by the type of transportation. So buses, minibuses, trams, trolley buses, and it's all visualized on the screen. Here on the screen, you can see, for example, that orange units are highly dense here and the blue one there. So it means that the fleet park is located there. So it's very fun, wonderful picture. It's very convenient. You can do real-time tracking, and according to my opinion, it's really convenient for efficient management. Again, if something is happening, you will immediately see, and you will be able to notice the situation and to apply any decision regarding this. Another layer is the cameras. Again, we have the network of the cameras located all around the city. You have statistics of operated cameras. What is more important, you can switch to any of them and you will immediately see from the different angle, for example, the desired junction. So you can see the situation in there. For example, if some accident occurred, you will see it immediately, and the emergency services can be called automatically. So again, it's very important for road security. Another layer is weather monitoring. So again, we have several stations monitoring the weather conditions, and they are displayed on the screen. Also, there is a layer for events monitoring. Again, if there is an accident or road work, everything will be shown on the screen. As well as other planned traffic development projects. For example, you know that in certain street there is a project for some changing in traffic conditions. Some project is being developed, and in the traffic control center, you can switch on the indication of this project, so the operator can see what other changes are about to be applied for the certain street. So to conclude this presentation, let's again describe the main advantages of the such traffic control center realized in RITM. So first of all, you have a huge number of functional blocks. They show perfect flexibility. So this structure overall can provide an efficient work with the data you collect. And this data may be of any type and origin. So the visualization is perfect and it's very convenient, and it makes comfort real-time data analysis using this interface. And this is just qualitative parameters, but numbers say everything. So according to the statistics, during these 2 years, let's say, if we speak about this current year, 2021, we already observed that the road congestion decreased by 8% to year 2020. And the number of traffic accidents decreased almost by 20% during the first 10 months of this current year. What is important more, that RITM system can provide some tools for deep analysis, for machine learning, so what I mean is that all the accidents are collected in the system, all the information, their location, their conditions. So not only the decreased number of the accidents is important, but that those accidents are further analyzed to change the traffic control in this location to improve the security in future. So there are many advantages, and this presentation could be much longer, but according to the reglement, I think it's enough for today. So thank you very much again, everybody, for this opportunity to share the experience between the countries. So I thank you. And if you have any questions, you can ask.